Okay, so you know how I'm always saying this is one of the most important things for the rest of the year because we're learning all this new stuff here at the start of the year that we're going to need the rest of the year. And this is one of those big deals, the reference angle. We're going to be using reference angles the rest of the year. They are a very big deal. So here's what it amounts to. Reference angle is the acute, less than 90, greater than 0, thus positive. So acute angles are automatically positive. So reference angles are never negative. So here's what it amounts to. If I draw an angle right here and say, okay, there's my angle. Well, that's definitely less than 90. Agreed? So that's less than 90. So that would be the reference angle. You are the reference angle right there. Now, here's where this is going to be a big deal, and we're going to have to spend a lot of time on this. We are going to spend a lot of time on this. If I draw a big old angle like this, if I draw a big old angle like that, say, well, there's my angle theta right there, then this guy right here becomes the reference angle. It's the angle you make with the x-axis. That becomes your reference angle right there. So it is the angle you make with the x-axis. And I should say this. The terminal side, terminal side, terminal side. So it is the angle the terminal side makes with the x-axis. And we call these central angles because they're made right there at the center. So these are central angles. They're made at the origin. Okay. And that terminal side is making that angle right there. So if you had said, all right, I've got an angle that's way out here in the third quadrant. So there's my angle theta way out there in the third quadrant. You'd say this guy right here becomes the reference angle. That becomes the reference angle because it's the acute angle you make with the x-axis. Same thing in the fourth quadrant. You go all the way around here, and you're in the fourth quadrant. You say, oh no, I've got a huge angle theta right there. So my reference angle is that guy right there. That's your reference angle. That little angle right there. It's the angle you make with the x-axis. So the reference angle is going to be a humongous deal starting as soon as you watch this. Okay. Going to be very big. And what we're going to do is we're going to go through and we're going to establish some rules for reference angles. Okay. Issue 1. We drew an angle in the first quadrant. So if I'm in the first quadrant and you say, okay, here's my angle theta. Well, your angle theta is already less than 90. So in the first quadrant, the angle theta is its own reference angle. In the first quadrant, you are your own reference angle. So first quadrant, you are your own reference angle. Now, when we just learned about degrees and radians a little while ago, we had 90 degrees was up here, which is also pi over 2. So what happens if we have a second quadrant angle? We have a second quadrant angle like this. So let's just say my angle is 140 degrees because that's between 90 and 180. So that's definitely second quadrant. Agreed? Definitely second quadrant. So who's my reference angle? Well, just like we said, our reference angle is this guy right here. So our reference angle is, so who would that be? to go from 140 down to 180, that reference angle would be 40 degrees. So my reference angle turns out to be 40. So I made this guy right here is my reference angle, 40 degrees. So it looks like we probably need to come up with a plan here. If I'm in the second quadrant, let me see, how did I find that 40 degrees? Oh, well, it was 180 minus 140, which made the reference angle. So in the second quadrant, the reference angle is 180 minus your given theta. This is if your angle is in the second quadrant. And then somebody yells at me and says, yeah, but what if we're in radians? What if it's pi? What if I'm between pi and pi over 2? Oh, well, instead of 180, we would say pi minus the angle theta. And that's how we would find that. Such as if I had, what's a good one? 5 pi over 7. If that was my original angle, 5 pi over 7 is in here. So we would say, uh-oh, I've got to say pi minus 5 pi over 7, which is 2 pi over 7. And that's my reference angle. And I showed like all this stuff. When you look at the worksheets, I showed the steps on that. Okay. All right. So what if I'm over here? What if I've got a third quadrant? See here, this is 180, 180 degrees, which is also pi. This is 270, which is 3 pi over 2. So if I had an angle that went all the way into the third quadrant, here's my angle theta. So if my angle theta, what do you want to call it? 230 degrees. So theta is equal to 230, which is definitely in the third quadrant. So you're saying, my reference angle is going to be this guy here. That's my reference angle there. There's my reference. So if my angle, how do I go back from 230 to 180? How many degrees is that? Well, from 230 back to 180 would be 50 degrees. So it looks like in the third quadrant, my reference angle would be the original angle theta minus 180 degrees. So 230 minus 180 made that reference angle of 50. And then somebody says, yeah, but what if it was in radians? Okay, in radians, instead of 180, it would just be pi. We're going to do a bunch of these problems. Don't worry. It'd be just theta minus, okay, pi, which I know I'm acting like, oh, that's no big deal. Okay, but I know it gets complicated because of all the fractions and stuff. Okay, so let's go into the fourth quadrant. And by the way, these formulas I'm writing here, these little formulas, they look like they're no big deal, but they're going to come back the rest of the year. They're going to be a big deal the rest of the year. In fact, whenever we get around to reviewing for the final exam, we always end up having to talk about these formulas again. Okay, so what if I had something like, what's a good one? 310 degrees. So I had 310 degrees, which is in the fourth quadrant because it's between 0 and 270 and 360, which is also 3 pi over 2 and 2 pi. So you're saying, there's my whole angle right here, 310. So this guy right here is the reference angle. So let me see, to go from 310 all the way to 360, to go from 310 to 360 would be 50 degrees. So I've got to basically just finish the circle. I'm going to the x-axis, the closest angle with the x-axis. So it looks like in the fourth quadrant, looks like my rule for the reference angle is 360 minus the given angle theta. So in radians, that would be 2 pi minus the given angle theta. So these first quadrant, you are your own reference. Second quadrant, to find the reference angle in degrees, 180 minus theta, pi minus theta. Third quadrant, theta minus 180, theta minus pi. Fourth quadrant, 360 minus theta, 2 pi minus theta. All right, so these are the formulas that we're going to need to know and love. And we're going to do a whole bunch of examples of those. Okay, I'll do those in another video, the next video.